So let's consider a small example. Assume I have this cupboard. You know, it's a cupboard, so how does it look like? Let me try writing it with my poor drawing skills. So you see, this is the cupboard I can think of. Thanks to the modern drawing technology, a very bad rectangle or a square becomes proper, you know. So people like us who are not very good at sketching can still manage. Alright, so how does a cupboard look like? So let me put a vertical line here. Then again, thanks to the drawing technology, it makes it vertical. Very good. So far so good. Maybe you should put this exactly to the center. You see, it even places it in the center. Wonderful. Okay. So, still doesn't look like a cupboard, an almirah or whatever, a closet. Depends on which part of the world you are in. Right, so maybe a handle here and a handle here. And you can open this cupboard. Alright, so now, imagine this cupboard is installed in a particular place. Right? You don't change the place. You see, you keep it like that. It's kept in a permanent place in your house. You don't change it or shift it. Let's say, as opposed to this, I want a cupboard which keeps moving. Alright, for some reason I keep moving it here and there. Alright, it's not installed in a particular place, but moved around. Alright, I want that to be mobile. Let's say I want this to be movable and mobile. Then what would I do? I would rather affix some wheels to it. You see, I'll put some wheels to it. Correct? Some sort of wheels so that it's easier to carry it around. Alright, as simple as that. There are some wheels here. And the cost is slightly more because you want an extra facility. This becomes an extra facility, you see. This is a little extra facility. That's it. A small observation. Right? You must be wondering, what are we doing? You know, sometimes when a teacher is not well prepared, he starts talking obvious things. So maybe yes, I'm doing that. Let's see if this comes in use somewhere in my teaching of this concept called tuples in Python. Alright, so I'll finish my teaching, and at the end you should guess what is this to do, whatever I said right now. The movable or the not movable facility, something that becomes extra and might even hike the cost a little. Right? What has this to do with Python programming, and especially the topic that we're going to discuss right now? Okay, just watch out. So consider a list L is equal to some entities here. Let's say 5, 7, 19, 10. We have been doing this from a long time. In fact, we can take random numbers, but I enjoy simply typing these numbers randomly. Right? So you can always add something to it. Correct? You can remove something from it. Once you add, you see what you have here is one extra element 100, and you can remove, let's say, an element 7 here, and it gets removed, so on and so forth. This is a known fact, right? Nothing surprising. But then, instead of doing it like this, assuming you created a variable t is equal to, you see, for a set, you used a flower bracket, right? Correct? For a list, you used big brackets. This is how we were taught in high school. At least that's how I was taught in high school. So for set, you use flower brackets. So what is left out, if you think for a minute? It is the small bracket. And in fact, Python uses it for something. Let me just introduce you people to what is called tuples. So T for tuples, T equals, if you use the small brackets, let me try that. 2, 7, 18, 64, 101, 108, and let's say 65, and so on. Right? So if you print T, or simply say T, whatever, you will get this with the small brackets. But let's see something. You could do append for the list, right? In fact, you have so many things that you can do with lists. I would strongly suggest that you look at all of them. You can append, you can clear the entire list, copy the list onto something else, count the number of occurrences of an element, find the index of something, extend the list onto a bigger list by adding another list onto it, rather appending some list onto it, so on and so forth. There's a lot of things that you can do here. Roughly how many do you have? Some, if I can count it right, some 11 possibilities with L. But then if you see T, you only have 2 possibilities. Which means the moment you create it, you cannot append anything to it. Let's try appending some 111, let's say. See, it throws up an error. Let me try removing something from it. Let me remove, let's say 7, which is the second element. It throws up an error. So what is T of 0? T of 0 is 0. You can access anything the way you access a list, but you cannot append anything, you cannot remove anything. A tuple is unchangeable. Let me print that statement so that you all observe it. A tuple is unchangeable. Okay? Whereas a list can be changed. A list can be changed. Okay, so there's a fancy word for this, immutable and mutable, copied from the word mutation in biology, but don't break your head. The idea here is one can be changed, other cannot be changed. You can ask me why would anyone want to have tuples this way? How easy would it be if we were to change tuples? But then what would be the difference between a list and a tuple? If you can change the tuple too, except for the way you write the brackets, everything would be the same. So let me think then, what could be the difference between a list and a tuple? So let me do one thing. Let me create a list of 10 numbers only, and the same list of a list of 10 numbers, which is, let's say if you print L, you will see 0 to 9, and then I'll say tuple 2. T equals, you would have guessed it right, you will say tuple range of 10. Okay, print T or simply T. Okay, you will see this. The difference between L and T is that L can be changed, T cannot be changed. Okay, so print L is flexible, but T isn't. Okay, I'm sorry, I missed that. You are even wondering why is he printing these statements. This is just to sort of imprint this on your mind so that it's like using a board, let's say a blackboard. Of course I can use my iPad to write, but then it's easier this way. Alright, so L is flexible but T isn't. So what's the point in having a T? This sounds like the example that you just now saw. A cupboard that has wheels and a cupboard that doesn't have wheels. You cannot say, oh, this cupboard doesn't have wheels, so I don't want it. You probably want a cupboard without wheels for some reason that you don't want the cupboard to be movable at any cost. You want it sturdily kept in a corner, right? Whereas, maybe you have a small cupboard, but you want to move around. Let's say, take it near your bed when you're sleeping and pull it near your living room when you're working. Maybe it has all your laptop and other digital devices. You see, there's probably an application of having something and not having something. Now if you are wondering what is the application of a tuple structure like this as opposed to a list structure, a list option in Python, tuple option in Python, what's the difference? Sometimes you may not want things to change. You may want to fix things and you don't want that to be changed. For example, you can put let's say I'll call it alpha, and then I will create all the alphabets A, B, and so on up to Z. In fact, there's a smart way to do this. I'll use the smart way. There is something called import string. Bear with me. String dot, there's a function, if I remember it right, it's here, ASCII letters. ASCII letters will have all the English alphabet letters, lowercase and uppercase. Okay, if you want only uppercase, maybe you have what is called uppercase. Okay, if you want only lowercase, obviously you would say lowercase. Okay, what am I up to? Why am I even using this? For me, I would say I will take S equals string of ASCII character ASCII underscore letters Okay, and then print S, you have everything. Wonderful. So it was very easy instead of typing, you see. I mean, so although I would prefer that you type it and keep it safely. So where are we heading towards? Just observe. I will create a tuple, let's say alpha, which is, I will convert this to a set to begin with. Let's say, what is set of S? You see, it takes individually and converts it like this. Right, so let's say S equals set of S, which means your S is no more a string like this, but it becomes a set, and that again gets assigned to S, and the string S is lost. As you can see, if you print S, you will have, you see, it's not even ordered, you know, A, B, C, D in some order it is. But I want this as a tuple, so alpha equals tuple of S. So print alpha. So it has all the characters. Maybe I will do one thing. I don't like this random ordering. I want the right ordering. It's a very easy thing to do. What I'll do is alpha equals what is that? S is equal to, what did I say? String ASCII letters. I'm done. And from this I'll say alpha is equal to tuple of list of S. Okay, list of S makes it, what is list of S? Let me show you. It makes it like this. Print list of S is like this. I tend to repeat the commands just so that I reiterate and it's easy on your minds. I can of course go fast, but it doesn't make sense given that I should match your thinking and your absorption rate. Right, that's why I tend to be repetitive. Some people who know stuff already or good at Python might find it boring, as in always. I'm sorry, I should look at the average of the intended audience. Alright, so far so good. So I create this. Now you know what is an alpha. Print alpha. You will get the tuple A, B, C, D, E, F, G, H. Now this is fixed. You cannot change this. Can you? You cannot change this. Now I'm going to use this for a small application. And what is that? That is, I will create a new string, namely x is equal to Sudarshan hash percentage, okay, ampersand, so on and so forth, okay. Then I'll say India, and then I'll say Bharat, and then I'll put brackets, and then I'll say Karnataka, and then Punjab, so on and so forth, okay. Tamil Nadu. I'll even include a space here, Tamil Nadu, and so on, right? So now, what I want to do is, maybe I'll change this to a list so that it's easy on our minds. I now want to remove anything that is not here, okay? I want to remove all the unwanted symbols and retain only the valid alphabets. So how do you do that? How do you do that? It's going to be a very simple, straightforward code. Let me write that here itself. Bear with me. I'm not going to open a file and then type it. You are now familiar with terminal. So very straightforward. Terminal is like a calculator. In calculator, you don't store anything. You go ahead and then simply type it. So that's what I'm going to do. I'm going to simply go ahead and then type my code. What do I do for, let's say, P in, I will not say X in because X is used already. For P in L, for every single letter you have, I'll first initialize an array, maybe an array R. Okay, what I'll do is for P in L, so Python is as simple as English, as you know. I'm iterating through every single entry of L here. What I'll do is I'll pick only the valid letters and put them into L. If P is in alpha, then I will append that to R. Okay, let's spend a moment watching at this. I mean, my intention is also to sort of get you familiarized with programming, programmatic thinking, thinking programmatically. For P in L, P is just a variable. It iterates through the entire list L, which is basically this. Initially P becomes S, and then P becomes U, and then P becomes D, and then P becomes A, and so forth, so on and so forth. And every time you check if P is in alpha. Is in is a valid way in which you, in Python, you say, if P is in alpha, true, it gets inside. If it's not in alpha, it doesn't get inside. I'm sure you're familiar with if now. You're also now familiar with is in, right? So this should be, okay, I'm sorry, I made a mistake. There is no is in there, there's only in there. Okay, never mind, mistakes do happen. You all make mistakes, so do I. Okay, let me console myself by saying that yes, there is no error here. Let me now say print R, and you get all the letters: Sudarshan, India, Bharat, okay, and then word and H. Did I type H somewhere? India, Bharat. Okay, India, Bharat, and Karnataka, and so on. Right, everything is here, and even the special symbols, including the space, is removed because space was not part of this alpha. Now the question is, you used alpha as a lookup, okay, to remove unwanted letters. Now alpha is fixed. You see, this particular alpha is fixed. This, you will never change this, will you? So this is alphabets, all alphabets. You don't want to change this. You don't want to change alpha, it's fixed. Alright? In such instances, when you don't want to change something, when you fix it, you use tuples. Now you can ask me, why not use lists? Because accidentally you might remove something from the list. Is that all? Is that all why you would use tuples? There's one hidden agenda why you use tuples. And I'll unravel it for you right now. Just observe. Let's say L equals, okay, so we have this L here, let me use something else. A equals list of, or let me use L itself, easy on the mind, list of range of 10, okay. T equals list of tuple of 10, and you see, what went wrong there? A tuple of range of 10, my bad. Tuple of range of 10. Okay, you have your list, you have your T. What was the question? The question was, why do we even care for a tuple except that it cannot be changed? We can as well use a list. There's a hidden benefit of this, and that is, you see, L underscore underscore, remember this, size of L is 120. Here's a beautiful function called size of that will tell you how much memory size L is using. Okay, what's your guess if I said size of T? Boom, that's 104. Do you see the point here? Do you see the point we discussed with a cupboard with the wheels and not with the wheels? Obviously, I would say the cupboard without the wheels should cost me less. Here is a facility where you don't want to remove it. This is stagnant. This is constant. You will not move it. Here you may have to add, you may have to remove. So your computer, Python, uses your computer to store it in a slightly different way so that it's flexible. With flexibility comes price, probably. That is why it says 120, it says 104. In fact, it's out of the scope of our discussion to actually get into the details of how exactly it is stored. But you can look up online with a little smartness, you will actually understand what's happening here. Alright, so good, so far so good. You now understood why list, why dictionary, why set, why tuple. Whenever you are very sure, let me just print that so that we imprint that on your minds. When we are sure of the list that we are handling, and we are also sure that it never changes, then use a tuple. Okay, so take this, put this in your mind, remember it, and please use tuples whenever you have, imagine you have a very, very big set of data and the data remains the same, you will never change it, so you can at least reduce the memory that you use. Alright, so a word of caution, don't break your head much about the lists and tuples and even dictionaries and sets and whatnot. I mean, need-based usage. Whenever you feel like using something, use it. If something is not working because it's the huge data that you're crunching, if it's huge data that you're crunching, don't worry, it will take some time for you to reach there. But when you reach there, you would have automatically matured to what should be used well. Right? You can always look up on the internet what is the best way to get something done. So as of now, just for the completeness sake, we have taught you the lists, the dictionaries, set, and a tuple. Okay, remember what is what. That should do for now. Good.